Question number 34. A circular coil of wire is in the region of uniform magnetic field directed out of the page. Okay. The area of the coil in the region varies with time as shown the figure. Okay, so area is changing like this. What is the induced current in the loop plotted with time? Okay, he is asking you to find out what is the induced current. Now, why do you get an induced current? Now, what's happening here? There is a magnetic field over here. Magnetic field is directed outwards. Okay. Now, there is a loop of wire present over here. Now, what does this graph tells you? The graph tells you initially this is the area. This is the area initially. Then after some time when it comes here, what happens? This loop is shrinking. This becomes like this. This becomes like this. This becomes like this over here. When it reaches here, this is what it happens. Then after some time, what happens? This becomes larger. This becomes larger. This becomes larger here, right? So it is increasing like this over here. Okay. So therefore, the loop initially is larger, then it shrinks, then it increases. So what? Why should you get an induced current? You get an induced current because when it is this much big, what do you see? You see 9 lines. Okay, I just take an example. There are 9 lines which are being exiting outwards. There's a large amount of flux over there. Okay. Now when it starts reducing, what will happen? When it becomes like this over here. When it becomes like this over here. When it encompasses only so much. What happens? Only 5 lines over here. When it becomes this much, what happens? Only 1 line, right? So therefore, there is a change in the flux being observed. Okay? As the area changes, there is a change in the flux being observed. So therefore, when flux changes, automatically with respect to time, your delta phi by delta t will also change. When delta phi by delta t changes, automatically there is an induced EMF. When you have an induced EMF, you also have an induced current. So this explains everything. Let's not start to solve the problem. I just explain the concept. Let me erase this. Let me erase this so that we write it freshly. Okay. Now what we do is, now we need to calculate the phi to understand this. The value of phi is given by B into magnetic field multiplied by area. Now this area is changing. So delta phi by delta t is nothing but B into delta A by delta T. Now in this graph, B cannot be determined. Area and time is given. What is delta A by delta T? Delta A, so if I write it in y-axis, area is nothing but y-axis. So I'll write this as delta y. What is delta T? Divided by delta T is delta x over here. It is nothing but delta y by delta x. What is delta y by delta x? It is nothing but slope, right? So what I will do is, this irregular curve, I will divide it into several regions to understand it. I take up one region here, almost a flat region. Region number 1. Okay, what is the slope here? If something is flat, then what is the region? What is the slope there? Slope is nearly 0. Okay, so therefore, now let us look into these curves. Okay, when I say slope is 0 over here, then your flux delta phi by delta t is also 0. When delta phi by delta t is 0 here, then EMF is 0, current is 0. Which means, look at this, current is 0 here. Current is 0. So current is 0 here at t equal to 0. Current is 0 here at t equal to 0. Current is 0 here at t equal to 0. Current is 0 here at t equal to 0. I can't put across any boundaries. I cannot say which one is correct here. Okay. Now let us first analyze all the plateau regions. Then we will look for the other one. Now look at this. There is one more plateau region here. I can draw a tangent here. What is the slope here? Here also slope is 0. Here also the slope is 0 over here. Right? 3 regions I get slope equal to 0. So towards it, I need to get the current to be 0 at t equal to 0. I'll write down at t equal to 0, at t is equal to t by 2, and at t is equal to t, at t is equal to t. At all these 3 regions, I want the current to be equal to 0. Let us find out whether I equal to 0 in all these regions, which curve will obey this. T equal to 0, t by 2, t. Okay, this is obeying it. Okay, this is also obeying it, right? And this one, this is maximum here. So this is not obeying. At t equal to t by 2, it is maximum. Current is not 0 here. So this is not the correct option. This is also not the correct option. So C and D are eliminated. Now 50%. Now we have A and B. Which of them is right? Now let us take up this region. Now in this region, what's happening? Area is decreasing. When area is decreasing, your delta A by delta T is negative. The slope becomes negative. Okay, or in other words, the current becomes negative. Now when the current becoming negative, which is possible? See here, current is becoming positive here. Current is becoming negative. So therefore, B is the right answer. A is in.